You all have given exams and waiting for the results, right? Okay. So children, today we are going to start a new chapter, that is chapter number 3, Understanding Quadrilaterals. And what we are going to study today in this chapter? We are going to study the first topic, that is polygons. In this we will study that what kind of figures are called polygons. Then we will study classification of polygons. That means how the polygons are classified on the basis of number of sides. Then we will study about diagonals. Means what are diagonals and how can we find out the number of diagonals in a particular polygon. Students, here you can see that few figures are drawn. Now we have to see that what are the differences in these polygons. Let's study these figures one by one. Let's see the first one. You can see in the first one that if suppose I am drawing this figure from this point, right? I drew the first side, then second side, then third side, and then fourth side. I can see that the starting point and ending point of this figure is common, right? What about the second figure? In second figure also, if I am considering this point as starting point, after going through all the border, means all the sides, I am coming to the same initial point. Means in this polygon also the starting point and ending points are common. Let's see the third figure. Suppose I am starting drawing this figure from this point. So I drew this side, then this, then this. But in this figure, I observe that the starting point and the ending points are not common. Just like that, in the last figure also, this is the starting point and this is the ending point. Means here also the starting point and ending points are not common. So, the figures in which the starting point and the ending points are common, they are called closed figure. They are called closed figure. These two figures are not closed. So, what are called polygons, children? Polygons, a simple closed curve which is made up of only line segment, is called a polygon. So, for being a figure, a polygon, it should satisfy the conditions. What the conditions are? First of all, it should be closed. It should be closed means its starting point and ending point should be common. Second thing, it should be made up of only line segments. Like these two figures are closed also and they are made up of line segments. So first two figures are called polygons. Children, here we will study about the classification of polygons. And here we'll study the classification of polygons on the basis of number of sides. Means if any closed figure, means if any polygon is made up of 3 line segment, then it is called a triangle. Tri means 3. Now the next one. If any polygon is made up by 4 line segments, then it is called a quadrilateral. Here quad means 4. Right? Now the next figure is made up by 5 line segments and its name is pentagon. Just like this, if any polygon has 6 sides, it is called hexagon. If it has 7 sides, it is called heptagon. Just like this, we can name a polygon on the basis of number of sides. If a polygon has 8 sides, then its name is octagon. And if any polygon is made up of 9 sides, it is called nonagon. And if any polygon is made up of 10 line segments, it is called decagon. Children, in your maths NCERT textbook, a table is given in which all these polygons are drawn along with their names and number of sides. So kindly go through that page because we can ask you questions in the exam on the basis of this concept. Our next concept is diagonals. So let us learn what are called diagonals. So what definition is given here, children? A diagonal is a line segment connecting two non-consecutive vertices of a polygon. Non-consecutive means, suppose I am talking about this quadrilateral ABCD. So the consecutive vertices of point A means of vertex A are B and D. But the non-consecutive vertex of A is C and of B is D. Right? So when we will join the non-consecutive vertices, we get a diagonal. Like in quadrilateral, when we are joining point B and D and A to C, which are non-consecutive vertices, we are getting two diagonals. The names of these diagonals are AC and BD. So these two line segments AC and BD are called diagonals of the quadrilateral ABCD. But children, if you have a pentagon, like here I have drawn PQRST. So in this also, when we will join the non-consecutive vertices, like if we'll talk about point P. So what are the non-consecutive vertices of point P? Yes, the non-consecutive vertices of point P are PR, R and S. So when you will join PR and PS, you will get two diagonals. Just like that, for Q, for R, for S and for T, when you will join the non-consecutive vertices, you will get the diagonals. And children, when you will suppose you are given a question that find the number of diagonals in a hexagon. In a hexagon means what, children? Yes, hexagon means the polygon which is made up of 6 line segments. 6. So how can we find out that how many line segments are, how many diagonals are there in that polygon? So there is a formula to find out the number of diagonals in any polygon. That formula is number of diagonals is equals to n into n minus 3 upon 2, where n represents the number of sides of given polygon. Let's solve for hexagon. Suppose we have to find out the number of diagonals in a hexagon. So in that case, the value of n will be 6. So how can we find out the number of diagonals? It will be 6 into 6 minus 3 upon 2. This 2 will cancel, 6 will get 3 over here. So 3 into 6 minus 3 means 3. So 3 3s are 9. In the case of hexagon, the diagonals are 9. Just like this, you can find out the diagonals of any polygon. You can find out of the polygon having 11 sides, 12 sides, up to any number of sides. So please don't forget this formula, which will help you to find out the number of diagonals of a given polygon. Thank you, children. I hope you enjoyed today's session. Thank you so much, and keep practicing the content which I are giving to you. Thank you so much.